So this is Module 3, Mapping to Attack from Raw Data. In Module 2, Katie talked about how you can map from finished intelligence reports into ATT&CK. Now I'm going to talk about following that same process and working with raw data or data from incident response instead. So everything so far, we've been looking at intelligence with activities already been analyzed, where it's already been written up and talked about what's actually happening. So now we're going to get into doing the analysis of techniques and behaviors directly from the source data that those reports are coming from. So this can have some upsides. There's likely more information available at the procedure level. There can be a lot more detail in the actual data. You're also not reinterpreting another analyst's prose, so you're deciding yourself on what the activities are. The downside is there can be a lot more knowledge necessary to actually look at this. So you might be looking at different data sources that require different levels of expertise, and you might have to be looking at a lot more data in order to figure out what the intent and tactic are of the actual behavior. So there's a broad set of possible data that can contain behaviors. This can be everything from shell commands, it can be malware analysis or sandbox detonation, it can be data from forensic disk images, it can be things like packets, packet capture, and it can be a number of other data sources coming from incident response or defense analysis. We're going to follow the same process that Katie taught in Module 2, going through each of these steps and trying to get to where we've got an attack technique and working to hedge our biases. So I'm going to skip step 0 this time, since it's identical to mapping from finished intelligence reporting, and it is what we covered in Module 1. So these are a couple of different data types that you might commonly encounter in looking at an incident. So first up, we've got a couple of commands that were captured by sysmon that were seen being run interactively via command exe by an actor. Next, we've got data from a couple of flows. This is from malware being run in a sandbox. And finally, we've got some registry keys that were seen being added during an incident. So finding the behavior. Well, with these commands, if they're actually being run by an adversary, each of them can potentially be a behavior. Similarly, the flows can be a behavior that we're actually seeing from the piece of software itself. And the registry keys being added can either be a behavior coming from the software or the adversary themselves. So the next step is to research the behavior. Depending on what sorts of information you're looking at, this can be very similar to analyzing data in a finished report. It can also be different. It can also require expertise in understanding what's happening in the particular data type. This can require experience in looking at network packets and being able to analyze forensic data, malware analysis, understanding what different Windows commands do, and many other types of experience. So you might need additional data sources as well to gather enough context to understand what the behavior is. And this might require additional questions going back to incident responders or the analysts that are pulling together this data. So in some cases, researching the behavior can be fairly straightforward. If you start searching through the ATT&CK website for ipconfig/all, it appears in one specific example, and it's an example of system network configuration discovery. We've got a little bit of description on what it's actually doing, and we probably have a pretty good idea already of what technique that behavior is going to be. But it can be a little bit more complicated. This other command line that was in there, we're running recycler.exe, we've got these crazy command line flags, it's something with a VSDX file. Don't have a lot of stuff here. So we can make some educated guesses on what this might be. And so that command line might look a little familiar to some people, but there's not really enough context here to be sure of what's going on. So let's pull together another data source. So if we throw this into a sandbox and do some file analysis on this, it gets run and it gives the following output. So this might look a lot more familiar. So we're seeing a banner here that is showing us that this is RAR. So it's an archiver. So okay, this has told us something. We can now go back and we can use every analyst's second favorite tool after spreadsheets, search engines, to go look for the flags, figure out what it's doing here. And looking up that -HP, we can determine that it's being used to compress and encrypt the file. So what about that last piece of it, that VSDX file? Again, going back to search engine, first result, we can see that it's a Visio file. Okay, so what's coming out of a RAR is not going to be a Visio file, so we've got a little bit more idea of what's going on. So it looks like somebody's pretending that this information is being compressed and encrypted as a Visio diagram, probably as a part of exfiltrating data, but a little bit more information would be handy. So next we go through and translate this behavior into a tactic. Well, we kind of cheated with ipconfig/all. This was a specific procedure that we only saw under system network configuration discovery. And that only falls into a single tactic, discovery. So we're done, right? Not quite. So we said at the very beginning of this that it was seen being run via sysmon. And sys is also within the execution tactic. So this recycler.exe that we analyzed, we can start to figure out what that is too. So we figured out that it's trying to pretend that it's Visio data, so we've got moderate confidence that this is exfiltration. If we could pull in some more information and other data sources around this, it might make it a bit clearer. But it's also in execution as well. This was run via the command line and was seen via sysmon, as we said in the beginning. So the next step is to figure out what technique applies. So similar to what we showed you with working with finished reporting, we may have enough information to get straight to here. So the procedure might map directly to a technique and tactic, and we don't really need to get through these other steps. We do need to be careful that it might increase our biases to just jump ahead. So as I showed, going through ipconfig/all, we've already got enough to say that it's system network configuration discovery. And as I mentioned, adding an execution, we've got that it's command line interface. And then this recycler binary, we've put together a couple things here now. We figured out that these command line flags mean that it's compressing and encrypting data. And so data compressed and data encrypted are attack techniques. So relatively easy for us to get to, but not to forget that it's also command line interface. So we're showing that a couple things are execution at the same time as there being other techniques. It's important to think about concurrent techniques. So with attack, don't just think about what's happening. Think of also how it's happening. There are certain tactics that commonly have concurrent techniques. So these are techniques and tactics like execution, defense evasion, collection, where a lot of the techniques are describing how things are happening, where other techniques are describing what's happening. And so some other examples of common ways that we see concurrent techniques happening. So data compressed, data encrypted are two things that often come together. If you're creating a zip file, you're creating a RAR like we just showed, these are both happening at the exact same time from command line arguments that are different parts of a command line. And so these are both in exfiltration. Another combination we often see closely together is spearphishing attachment user execution. We often see in reporting that a spearfish is coming with attachment and a user clicks. This is user execution. So this is initial access and execution happening together. Data from local system and email collection can be the exact same activity. So where an actor is grabbing a PST file, so two different types of collection happening at the same time. And finally, a lot of these discovery techniques can be command line interface, where there are Windows built-in commands being run one after another. So there are also different types of techniques with an attack. And so not all techniques are created equal. Red Canary has created a nice blog post about this, as well as a talk at 2018's ATT&CK talking about these different types of techniques. So some are very specific. We have things like run DLL32, which are talking about a very specific mechanism. Some are broad, so scripting covers a huge variety of activities, as does things like obfuscated files or information. They also can talk about different types of things. So as I was talking about before, some capture how the behavior occurs. So something like masquerading, that's going to be in conjunction with another technique, or data transfer size limits that are likely going to be combined with some other form of exfiltration. And so finally, the last step, very similar to finished reporting, you're going to want to compare your results to other analysts. So there's the same caveats here as what Katie talked about earlier about hedging biases. We want to make sure that we're bringing together diverse viewpoints in order to have our best analysis possible. But there's an extra hiccup here with working with raw data. We may actually need a broader set of skills and experience to work with different types of data. So we might have one analyst who's comfortable working with things like packets, malware, reverse engineering, and looking at different types of data, as well as looking at the Windows command line and understanding what various commands actually do. Where we have another analyst who we need for the exact same incident who might be comfortable looking at Windows event logs, looking through disk forensics, or might be familiar with other platforms such as Mac OS or Linux. With each of these steps, there can be a lot of differences between looking at these two types of information that we've showed you how to map into ATT&CK. So starting with the first step and finding the behavior. With raw data, if you're actually looking at data and information that's coming from adversary activity, nearly everything can be a behavior. Now, that's not to say that everything is an attack technique. Attack doesn't include every single possible thing that an adversary can do. In finished reporting, the behaviors might be buried amongst other pros and amongst indicators of compromise and scattered throughout the report. For researching the behavior, with raw data, we might have to look across multiple sources to actually understand what behavior is happening, or multiple data types at the same time. On the upside, the activity might be a known procedure, so we might have enough detail to sort of dive straight into a technique. In finished reporting, we might already have more information or context that another analyst has pulled together for us, but we might also have lost detail that an analyst chose not to include in their finished report. As we translate the behavior into a tactic, in order to be able to map to adversary intent, it might take a lot of domain knowledge and expertise to understand what an adversary is doing and what they're trying to do. Whereas in a finished report, that might have already been done for us by the report author, where they've speculated about what the intent is. In finding what technique applies to the behavior. So if we've already found a procedure that goes straight to a technique, this might be really quick. Or it might actually require deep understanding of the specific data type in order to understand really how that activity was accomplished. In the case of a finished report, it might be as simple as a text match with something that we've already mapped in ATT&CK or a procedure that's already in ATT&CK, but also too much detail might have been lost in order to tell what technique it is. Finally, comparing your results with other analysts can be a little bit different. With raw data, it can be really important so that you've got analysts that can cover all the different data sources that you're pulling in. Whereas with finished reporting, it can also act as a hedge against biases, and so that you've got multiple analysts coming to the same conclusions. So next, we'd like you to do an exercise where you're going to be doing some of this mapping from raw data yourself. So we're going to have you examining 2 tickets from a simulated intrusion incident. So the first ticket you'll be looking at is similar to the examples I showed before, where you've got a series of commands interactively executed via command.exe on an end system. The second ticket is going to be pieces of a malware analysis of the primary remote access Trojan used during the incident. So you'll be able to find both of these tickets at attack.miter.org/training/CTI under exercise 3. So download these 2 tickets and use whatever you want to record your results. You can edit the tickets directly. Try to identify as many behaviors as possible within these tickets, and then work through this process we've given you to annotate the behaviors that are attack techniques. So we'd ask you to please pause the video, and we suggest giving yourself up to 25 minutes to do this exercise. Welcome back. So some of the things to think about as you think about the experience doing that exercise. So first off, what additional questions would you have asked of your incident responders? What was not enough information here for you to really figure out what was going on? You might have wanted to pull in more data that we didn't give you. Did you find this easier or harder than the exercise in Module 2, working with finished reporting? And we find a lot of people find that working with the raw data information is a little bit easier. You don't have other things around it, and you can drill right to the behaviors. Are these the types of data that you actually commonly encounter when you're looking at activity? Or are there other things that you think should be in there for behaviors? And did you find any behaviors where you couldn't actually map those to a technique? So I'd like to go over the exercise itself, as well as how we mapped the various activities that are in here. So first off, ipconfig/all. And we use this as an example throughout the beginning of the module. So this is fairly directly to system network configuration discovery. ARP-A is another one that you'll find directly within system network configuration discovery, so the same technique twice in a row. The echo user domain username is showing who the adversary is currently logged in as. So this is system owner user discovery. Task list/v is giving a list of processes currently running on Windows. This is process discovery. SC query is looking at all the different services running within Windows. This is system service discovery. System info is showing a broad set of information about the configuration and patch level of the systems. This is system information discovery. Net group domain admins. So this is showing a specific domain group and the members of it. So we would call this permission groups discovery. Net user/domain, we'd call account discovery. Net group domain controllers. So this is looking at the list of domain controllers that are within the domain that the adversary has found themselves in. So this is remote system discovery. NetSH firewall. So this is showing, again, system network configuration discovery. And then finally, netstat-ANO is showing all the connections that the system currently has. And so this is system network connections discovery. So you might notice that all of these techniques have a common word in them, and that's discovery. So these are all within the discovery tactic, and that's not all that uncommon, an adversary going through and doing a number of discovery commands in a sequence. We're not quite done. Similar to the examples we showed earlier in the module, these are all execution, so command line interface. So these were all run on command.exe, and we saw them through sysmon. So the second ticket's a little bit trickier. So this is text information coming out of a remote access Trojan, some flows, some activities that are happening behind the scenes. So first off, we have that the C2 protocol is base 64 encoded. And so that's data encoding. It's commands over HTTPS. HTTPS is a very standard application layer protocol. We have that it's downloading files. So this is remote file copy. We have that it's able to do a shell command. So this is execution command line interface. Similarly, we have that it can do PowerShell commands. So this is execution PowerShell. We have that it can execute a PE via an API call. And so that's this create process here. And so that would be execution through API. And you'll notice that not everything here translates into attack. Attack doesn't cover every single behavior that a piece of malware or an adversary could do. Then looking at these flows. So there's not a lot of information here. The IP addresses aren't that meaningful, other than one being private, one being public. We can see this port 443, which is a very commonly used port. We have that they're trying to copy something that's trying to pretend to be the legitimate winspool.exe file. So that's masquerading. And finally, we have the adversary adding a run key. That's actually in the list that you'll find within registry run keys. Now, if you had different answers than us, you're not necessarily wrong, but we would encourage you to take a look, go back, and look at how your mappings differ from how we've done it and the information that we have within each of these techniques. So now that we've gone through a process of mapping this raw data into attack techniques, I'd like to talk about some of what you're likely doing with that information. We've talked already about augmenting finished threat intelligence reports with attack, and then analyzing original data into attack, possibly to actually create these reports in the first place. And so we have some tips for people that are trying to create those finished reports, either from augmenting reports or from the original data. So the key thing is that we recommend keeping the techniques with the related procedures and the information around it so that there's enough context for people to understand the mapping. So this allows other analysts to examine the mapping, see if they understand, and make sure that everyone's on the same page in terms of what maps to what. It also allows for much easier capture of these procedures, and this might be important for crafting defenses against a very specific adversary behavior. So to give a more concrete example of what we mean here, so this is a reporting format that we've used ourselves. So, we're adding footnotes here with the individual techniques. So instead of disrupting the report, adding the techniques in line, we're just adding some footnotes pointing at where we're seeing each of the techniques. And so they're staying with the original data. We've often seen some good reports too where people have taken the techniques out and extracted from the report the portion of information that actually describes the activity. This is somewhat similar to the format that we use in our procedure examples ourselves with an attack. We're suggesting either of these or anything where the context is staying with the technique instead of doing an appendix that's just a list of attack techniques. So this is sort of similar to having an indicators of compromise at the end of a report that has an IP address there that you have no idea what it actually means, if I'm supposed to block it, what I'm supposed to do with it. And so that context can be really critically important. In this module, I've taught you how to take the process that Katie taught in Module 2 for turning finished reporting into attack and applying that to raw data. I've also given you some tips for what you can do as you turn that raw data and attack techniques into finished reporting. In Module 4, Katie's going to teach you how you can store and analyze that attack map data in order to make it actionable. This is the end of Module 3.